In this lesson, we are going to learn how to control the car by moving it using the code. We learn how the car moves forward, backwards, moves to the right, and moves to the left and stops. Then we are going to learn how to move the car forward, speeding up slowly, or backward, speeding up. Then we are learning how to control the speed of car using the code, so the car will speed up or slow down. Welcome to Arduino course by Robojax. This course is based on SunFounder 3-in-1 Arduino kit sold on Amazon. Everything that you learn in this course is included in this kit. The course comes with tons of components and projects, all with instruction and video for smart car and other projects that you can use for school or home automation. You can purchase it from sunfounder.com. The kit also comes with full documentation, code download, learning projects with full explanation, wiring diagram, and the code that you can download. The link to purchase the kit and documentation is below the video in the description. Welcome to Arduino course by Robojax. Now if we come to the documentation page under car project, we did the first project to make the car move. Now we are going to move the car using code. So this is code number 2, and we will connect 4 extra wires so we can control the moving of car using Arduino. This is the front of the car, and in order for the car to move forward, these wheels needed to rotate in this direction. Let me connect the wire. I've already loaded the code, so this is rotating in clockwise direction and this is rotating in counterclockwise direction. Because if you look at this, and here, you see this is rotating in clockwise direction and this is in counterclockwise direction. That's why this car is now moving forward. For the car to move backwards, the right one needed to rotate in this direction, counterclockwise, and this one needed to rotate in clockwise direction so this car can move backwards. Let me connect the wire. So this is backwards because that is the front and the wheels are rotating clockwise and this is counterclockwise. For the motor, for this car to turn left, we need the left wheel to rotate clockwise direction and the right wheel also rotate clockwise. So when this rotates clockwise, this goes forward, and when this rotates clockwise, this moves the car this way. As a result, it will rotate to the left. Let me connect the power. Now you see one is rotating the other way, and if I leave it, it will rotate to the left. Now, for the motor to rotate to the right, we need this section, the right section, to come backward, and the left section needed to go forward. So we have 2 arrows like this, and for that, this needed to be rotate in counterclockwise direction, the right wheel, and the left wheel also needed to rotate in counterclockwise direction. So this side goes forward and this backwards, and as a result it will rotate to the right. Let me power it up. You see, counterclockwise, and this is also counterclockwise. Let me just put it. So now this is rotating Let me grab it. Yes. And here we are removing the 4 wires that we connected in our first project, and we are connecting them to these pins. In 1, in 2, in 3, and in 4. As you can see, in 1 is connected to pin 5, in 2 is connected to pin 6, in 3 and 4 are connected to pin 9 and 10 respectively. I'm connecting these wires as shown on our diagram. I'm using yellow and blue. So first yellow, then blue, then yellow, then blue. And here the 4 wires connected in the same order to pin 5, 6, and 9 and 10. So this project is different when you apply the code. Make sure that these 2 wires that are connected, the red to 5 volts and black to ground, these should be disconnected when you are programming and connecting the wire. Once the programming is downloaded to the board, then disconnect and connect these back to 5 volts and to ground, and after that we can connect our battery and the car will move. This is very important. If you connect your USB while this wire is connected, this will request a lot of energy from our USB, and the USB will turn off, and that's not a good idea. Now let's open the project by clicking on File, Example, go to your kit and then click on Car Projects inside 3-in-1 Kit Main, and number 2, Move. Click and open. And here is our code. We have defined in 1, in 2, in 3, and in 4. We have used pin 5, 6, 9, and 10. These are the pins that are pulse width modulation enabled, which means they have this sign beside them, all of them. Inside the setup, we are getting all these pins and defining them as output. Inside the loop, this is a function that moves the car forward for 2 seconds. This delay is keeping it in that direction for 2 seconds, and then this stops the car, which I'm going to explain one by one. Stop the car for half a second, 500 milliseconds. Then this line moves the car backward for 2 seconds and then stops for half a second. This turns the car to the left for 2 seconds and stops for half a second. This turns the car to the right and keeps it for 2 seconds, turning to the right, and then it stops for half a second. Now each function is explained, which are below. Now when you want to move the car forward, these 2 belongs to one motor and these 2 belongs to other motor, and 1 and 2 are connected to motor 1, and as I explained it in the introduction, so 1 is low, the other is high, the motor just rotates, and the other motor, because it's located on the other side, because we have connected the wires flipped, so the N3 is high and 4 is low. I wish they've connected it the same way, so this would have been low, high, and then low, high. But I'm following the diagram from SunFounder. And then for the backward, backward is exactly the opposite of forward. So low and high and low. You see 2 high at the middle and then low, low. And here we have high and then the low at the middle. So this is changing the direction of rotation of one motor, and this is for the other motor. As a result, the car will move backward. Now let's see for right. I'm creating space. For right, we have high and low for one motor, and then again high and low here. So this is rotating in right direction, and also this is helping him. So the motor will rotate directly to the right. And for the left, it should be the opposite. This in 1 and in 2 will be low and high. Let's see. Yes. So in 1 and in 2 is low high, and in 3, which was high low here, now it's low high. So it turns to the left. So stop means apply brake, all of the pins low. So this will apply brakes, or stops as fast as it can. We learned how to move the car forward, backwards, turn right, turn left, and stop. Now it's time to learn about speeding up or slowing it down. Now let's open the speed control code. Click on File, Open. Go to the folder where you downloaded inside the 3-in-1 kit main. Double click, open car project, and go to number 3, speed up, and open speed up. And here is the code. Nothing has changed in the definition and the setup, but here inside the loop we have a for loop that starts with I equals 0. It goes up to I equal or smaller than 255. So that's the value for the motor, and then the I is the speed. So for the move forward, this is a method. This is a function at the bottom of the code, and we are passing I. So I will be 0, and then it comes here, I becomes 5. So 5 is added to the 0. So it will be 5, and then compare less than 255, move the car forward, and then go 10, 15, 20, 25, 30, and so forth up to 255. And in every step we have half a second. So this will be very long. Because 325 seconds, almost a minute. So 2 minutes. This will take about that much. So this is incrementing. Now this one I have defined here as 255 when I is greater than 0. So this is now decrementing by 5, and I initially is 255, and it goes to 50, to 45, to 40, to 35, to 30, and it goes up to 0, and it will stop. A loop will exit, but for each step we have again half a second. When it comes up to this point, it repeats all over again. Now let's see what the move forward does. Move forward, we have the pin using analog right. Remember, this is a pin number, and then this is a speed value. Move forward, it says initially this is 0, and we are passing the speed for one motor. One is 0, the other is the speed, and then for the other motor we put the speed and 0. This is low, and this will become high and up, high and 0 continuously, but consider this as high to understand it, because this is 0, and this is going high and low, and this is always 0. So this speed is coming that I that we pass here as an integer. In order to understand the code better, I have added these lines. First, I've defined the serial monitor with 9600 baud, and I'm printing these texts on the serial monitor. And then immediately after the loop, I mentioned that to print this loop 1 speeding up, and this will happen. Inside the loop, I'm printing I equal and then the actual I. And then when that finishes on the serial monitor, loop 2 slowing down, and inside the loop, we are just printing the I, so you know it is being decremented. Now, to speed this up, I'm going to make it 5 times faster, 100, so you can see it better. And after that, I'm going to stop it. So one way to stop is while 1. So I'm just stopping it for fun. And here, if I open the serial monitor, it prints it like this, 100 milliseconds. And loop 2, when it reaches 0, it will stop. So now let's review it. We first printed this text, lesson 3, speed up. So this is not lesson 3, I made mistake. So Robojax. So first we print this text, and this line just before the loop, it says speeding up inside the main loop before the for loop, and I is 0, and then it becomes 5, 10, 15. So this is incrementing by 5, but we are waiting very little inside. The delay is very small, so increment of 5. It reaches 255, and this is done. It goes to the next loop, which is slowing down. It starts with 255 and decrements by 5, and it goes down. When it reaches 0, the loop will start all over again, but I've stopped it for this tutorial purpose. Now I've powered it up externally, and in order to see the value on the serial monitor, I've connected this USB here. So now this is slowing down. Around 30 it stops, and again speeding up. So this is just going forward in this direction. And here is the code that I've written to control with a fixed speed. Up to here is exactly the same. So here inside the loop, we use move forward, and then the car will move forward with 255, and then we print forward at that 255 is printed in serial monitor for 5 seconds, and then we print this text stopped, and we send 0 to move forward. The same way you can send 0 to backward as well, and this will stop the car for 2 seconds and then move backwards at speed of 100, and then we print it on the serial monitor and keep the car moving for 5 seconds, and then we stop with sending 0 for 2 seconds, and the loop will continue to do the same thing all over again. And here, if you open the serial monitor, it prints the text, this text 255, and then it stopped, and then at reverse at 100, and then it stopped. So then it will repeat again 255, 100, and stop. And here is a demonstration. Let me reset it by pressing this button, so you can see from the beginning. Maximum 255 forward, as you can see, stop, and then it goes reverse at 100. This is very slow. And then again 255 forward. So this way you can send, so just use forward or backwards and put your value, and the car will move, and the car will move. If you want to stop it, just put 0. Now I'm outside because we need a lot of space to test this. So speed is very low. one motor is slowing than the other. When the obstacle gets closer to her or more space, it will turn in that direction and will proceed. Make sure to subscribe so you get updates when the video is uploaded.